Welcome everyone. In this video lecture, we will solve a problem based on diode and it is from the Microelectronics circuit book. So the question is, a square wave of 6-volt peak-to-peak amplitude and 0 average is applied to a circuit. So the input voltage Vi is given 6 volt peak to peak. So here this one is the waveform minus 3 volt the lower end and 3 volt at the peak, and this one is the square wave. Okay, and this we can say this point is say t by 2, having this waveform has a period t by 2, and this point is say 0 volt. Okay, so and there is a diode and resistor. So this is very simple, half a rectifier, and this resistance is 100 ohm. So we have to find the peak output voltage, average output voltage. Okay, peak output voltage, average output voltage, peak diode current and average diode current, and maximum reverse voltage across the diode. What should be the maximum reverse voltage across the diode? So first of all, we have to first draw the output waveform. So what we can say, we have to consider case 1 when the waveform is in between 0 to t by 2. Okay, for this interval 0 to t by 2. Okay, so this value Vi is negative minus 3 volt. So diode will be in the reverse bias. So simply the diode will be in the reverse bias. Okay, so the circuit will be open and there will be no diode current. Okay, so the circuit will be like this. Okay, this voltage will be like minus plus, simplified circuit V naught R, and this one is 3 volt, so minus 3 volt. So the current will, it is open circuit, so the current I will be 0. So V naught will be simply 0 volt. Okay, so in between 0 to t by 2, the output voltage will be simply 0. Okay, I'm just making it 0. Okay, now for the next half, say case 2. Okay, in the interval t by 2 to t, in this interval. Okay, this diode become forward bias and the voltage is 3 volt. So the equivalent circuit we can make like this. Simply we have to give a 3 volt. Okay, diode will be forward bias, so I am just short circuited this one. Okay, ah, okay, so in this case the output voltage V naught is same as that of this input voltage. So V naught is same as Vi, that is our 3 volt. So in between t by 2 to t, it will give the same. Okay, we have to go, it will same as that of 3 volt. So we have to make it like this. Okay, this one is our 3 volt. So this one is the output response. Width is more, but this one is just simply for the representation. T by 2 to t, it is 3 volt. Okay, so this one is the output waveform for this circuit. Okay, now we have to think the average value, peak value, everything. So here diode will be in the on state. Okay, or forward bias, we can say forward bias. Okay, and here this one is in the diode in the off. Clear, reverse bias off. So now we have to first thing, we have to find the peak output voltage. So peak output voltage, so peak output voltage will be here, peak output voltage V naught peak. So we can simply write here V naught peak. Okay, will be simply our 3 volt. This 3 volt will be the V naught peak. Okay, peak output voltage. Okay, then we have to find the average output voltage, peak diode current. Okay, so first we have to find the output voltage peak one. Okay, so the output peak current I peak. Okay, then we will find the I peak equals to means, or we can say id peak or anything, we can write id peak v naught peak by r. Okay, so simply it is 3 by 100. Okay, so it is simply 30 milliampere. Okay, what we can do, we can multiply with 10 up and 10 down, so 30 milliampere. So id peak, okay, will be 30 milliampere. So now we have to find the average output voltage. Okay, so for any waveform, the average one, okay, I am writing here, v average equals to 1 by t, 0 to t, vt dt, average value calculation. Okay, so here we have to find the peak output voltage. Okay, I am just mentioning this one. This we have calculated the peak output voltage and peak diode current. Okay, this peak output voltage, okay, wait, this peak output voltage will be simply our 3 volt, this 3 volt, and peak diode current, this 3 by 100, that is our 30 milliampere. These two we have calculated. Now we have to find the average output voltage, then after we will find the average diode current. Okay, so first we have to find the average. Okay, v average. So here what we can do, from this circuit v average we can easily find. I am taking v average 1 by t, the overall period. Okay, then 0 to t by 2 voltage in between this, so 0 dt plus t by 2 to t, okay, 3, this voltage is 3, okay, dt, clear. So this one is 0, so one can write 1 by t, this should be our simply 0, okay, and 3 dt means simply t, t, t to t by 2, simple calculation is there. Okay, for average calculation, so one can write here, I am writing here 1 by t into 3, it should be t minus t by 2, simple calculation. So it should be 1 by t into 3 t by 2. Okay, so the average one will be 3 by 2, very simple. That is our 3 by 2 volt, means v average voltage will be 3 by 2 volt. So v naught average become 3 by 2 volt. We have already solved here 3 by 2 volt, or simply 1.5 volt. We have already calculated this average one. Now we have to find the average diode current. Average diode current, that is our id average. So what we can write, v naught average value by r. So v naught average value is simply we have find 3 by 2. Okay, so make it 3 by 2 into r is 100. Okay, so this one is the average one, or one can write 1.5 into 100. Okay, or one can do, if you multiply with 10 and 10, it should be 15. So 15 by 10 power 3, so 50 into 10 power minus 3. Calculation you have to do very carefully, means 50 milliampere. So 50 milliampere will be the average one. Okay, so once again I am just mentioning this one. Average output voltage and average diode current we have calculated. So average one, the average, okay, this average one, average diode current 1 point, average voltage, sorry, 1.5 volt, and this one will be 15 milliampere. Okay, these four we have calculated. Now we have to find the maximum reverse voltage that a diode, maximum reverse voltage across the diode. So for the maximum reverse voltage across the diode, okay, I'm writing here maximum reverse voltage across the diode we have to find. Okay, reverse voltage means we have to give input in between in between 0 to t by 2 when we are giving a negative voltage. So when we are giving the negative voltage, it is a 3 volt here. During that time, this diode will be open and no current. Okay, so this value, this one will be reverse V, or sometimes it is a V P I V. Okay, peak inverse voltage, and the current will be 0 in this circuit. So if you apply Kirchhoff's voltage law in from any side, okay, so -3 plus VPIV, or maximum reverse voltage is this one. So VPIV, or maximum reverse voltage, will be 3 volt. Okay, so this one is the answer. So this is all about this simple question, and it is from the microelectronics circuit book. So VPIV we have calculated. This one is the maximum reverse voltage that I arrived. So it is in between 0 to t by 2. Okay, so we have to make like this, negative one, this one, and it should be open. So and the current will be 0, so there is no role of the resistance, simply just apply Kirchhoff's voltage law. So this is all about this one. So this one is our average value. Okay, we have already written here, and the average current. Okay, peak current and peak voltage is very easy, but for the average calculation we have to know this formula, or for the this one, for the this, better to highlight this formula. Okay, clear? So for here 1 by t we have break 0 to t by 2 with 3 by 2. So this is all about this question. So thank you for watching this video. So before that, I also want to highlight this answer, maximum reverse voltage. So the maximum reverse voltage for this one will be simply our 3 volt. Okay, so thank you for watching this video.